Hi, everybody. Testing on the, can you guys hear me? We're good. All right. Awesome. Yeah, welcome to Measuring the Business Value of Agents. Quick agenda. I'll go over a bit about myself, why I'm up here today. We'll talk about what the heck is an agent, because I think that we're all here to see that a little bit. We'll talk about business value and what we want to define as that, and then we'll go over 3 steps to measuring that for agents. Now, I know what you're thinking. First off, who the heck is this guy? Especially since I was just introed as having 2 talks today. So my name is David Tepper. I was with Microsoft for 19 years. Been in the Gen AI space a very long time. My first patent in Gen AI was in 2011. I ran internal Gen AI consumption for Azure's 45,000 employees. And then in order to pursue my own company, I decided to leave instead of taking on the role of reporting to the CTO of Microsoft and running internal Gen AI consumption across the whole company. While I was there, I was Microsoft's representative for speaking about Gen AI to Fortune 500 companies, universities, and to the US Congress. And about 6 months ago, I spoke in front of the United Nations, and I'll be giving that same UN talk later today. So if you're interested in understanding more about the problem of AI alignment, do stop by. So measuring business value is really hard, even just forgetting the agent part of it, right? And Gen AI is also really complicated. And so this is a picture of me before I went down this road. All the hair has been gone since starting my own startup. So let's actually dive into this a little bit. What is an agent? Raise your hand if you are an agent. It feels like everything today is agentic. I'm an agent. You're an agent. I saw you raise your hand there. I appreciate that. You're an agent as well, right? We're all agents, right? So everything these days is called an agent, but that is obviously way too broad. Everyone needs that they have to say, oh, we're working on agentic software. I'm going to post this on LinkedIn. It's the coolest thing ever, because you need that in order to stay relevant. But in order for us to actually work through this, we're going to have to define an agent in a little bit better terms. Now, working on this for so long and talking with hundreds of enterprises, there's really 3 categories that they tend to fall into. The first of these is what we call a workflow. So this is, think of a traditional piece of software, standard software, not necessarily using AI prior to Gen AI, and then it's incorporating generative AI into one of its steps. Most common use of this is to convert unstructured data into structured data. So if you are processing tickets from a bunch of people complaining about your software and you're trying to put that into categories of buckets, and it's turning their comments into predefined things, that's what we'll call a workflow. You're integrating Gen AI into your existing workflow. The second, and probably the most common right now, is what we call a pipeline. So this is a series of predetermined steps that leverage Gen AI at one or more of those steps. And so a chatbot is the most common of these. You ask a question, and it's going to do maybe like a RAG search, retrieval augmented generation. Hopefully folks are familiar with that. If not, we can talk about that. Where it's going to go look up a bunch of additional data. It's going to insert that into the chat. And it's doing a series of predetermined steps, not making any decisions of its own, always in the same exact pipeline, okay? There's a lot of processing that's happening at the enterprise scale, which are, again, pipelines. And then the last of these is actually agentic. So an agent that we'll classify here as agentic is something that is capable of making its own decisions at runtime. You give it kind of a broad task. It's got a series of tools and inputs that are available to it, and then it's going to spider out and figure out what it needs to do and execute for some extended period of time. Coding solutions are the most prevalent of these today, but this is where everything is headed. I think we're all pretty keenly aware of that. So now that we have an understanding of roughly what an agent is, what is business value? The business value can feel really different depending on the type of business that you're in. For example, if you're taking care of the elderly, business value might be like the warm and fuzzies that you get when you improve somebody's day, right? But in order for us to be able to work on this in a measurable way, we have to talk about business value via the mechanisms that are quantifiable. And so, again, we've been talking about business value with hundreds of enterprises, and they seem to have lined up into 3 buckets as well. It's kind of a coincidence. The first of these is value generated in the form of currency. And we'll use dollars here, just because we're in the United States, but obviously, that can span whatever currency. And this is typically as a result of either new revenue or savings. Right, either one of those. Entirely new revenue streams are really possible now with Gen AI. There's $80 billion a year being poured into startups for exactly that reason, but also we're using it to automate a lot of jobs away. Hashtag AI is taking our jobs. And so this is part of where that comes from. The other one is time savings. As a human, I used to need 10 minutes to accomplish this thing, and now with AI, it takes me 1 minute or less, right? It's something along those lines. So all of us are in some way hopefully getting some time savings back from agents, at least that's their goal. And the third of these is productivity. Productivity has 2 units. There's the thing that you're doing and the unit of time step away from the pictures here. There's a unit of time at which it's occurring. So for example, I used to be able to process 500 tickets a day, and now with my, my agent, I can process 1,000 tickets a day, right? So there's like a productivity lift as a result of that. And so we'll go through each of these one at a time. So let's start with, actually before I get into this, let's talk about why measuring this is hard. So what is the value of a human employee, right? How do you even think about that? For each of the 3 different types that we went through, you're going to have to, again, quantify that in some way. And so looking at financial value, this is the world's most basic ROI equation, right? This is nothing new. Everyone's familiar with this. And so in order for you to be able to measure financial value, you have to be able to fill in the variables here. You have to understand your net profits, right, of course, and then you also have to understand the cost. Now, the cost is unfortunately quite complicated for Gen AI. Normally, if you look at 2 different products, and if you think that they have the exact same cost, and I use them in exactly the same way, then the price that I pay is identical. But that is absolutely not true with large language models. Not every billing system for large language models is based on tokens, but the ones that do use completely different tokenizers. And so I can take the exact same sentence across 2 models with identical pricing, and the cost is completely different. If you want to switch to a new model, and this is true, how do you know whether it's going to end up being more or less expensive? Talk to me afterward, and I'll tell you a fun story about Grok. Text is not the only modality we work with, though, right? We work with images very frequently. We're passing in images that are then interpreted by the LLM. This is called vision. But you also have all of these other modalities as well. Now, how do tile tokens work? So this is actually the mechanisms by which an LLM is going to look at an image and then make a decision about it, incorporate it into the conversation, like reply, like, oh yeah, there's a hamster in this picture, thank you, right? But under the covers, they're charging you for that. And they charge you for that by applying very cockamamie mathematical equations. These sections here that are variable, they change those under the covers all the time. We have to actually go in and recalculate some of these. The input token price, we're all familiar with token prices changing, but those other numbers, the tile token number and base token number, did you guys even know you're being charged for stuff like this? Right, so OpenAI will just stealthily change the price that they charge under the covers. Very difficult to know. Now, this is just for the latest snapshot of GPT-4o. You go back to any other model that's leveraging vision, totally different equation. You look at earlier snapshots of GPT-4o, totally different equation. Look at other modalities, audio, video, all these things that were increasingly becoming multimodal because they want to be able to incorporate all of the information in their training data that we have on the internet, right? They were operating with text before as large language models. Now they're the multimodal language models because they get more training data that way. In fact, audio was added originally so they can incorporate podcast training data to make the models smarter. Turns out that the pricing matrix is actually far more complicated than you think. So this is GPT-4o pricing. And it's actually slightly out of date because they added something called the Responses API to replace the Assistant API, but I can't update this slide fast enough in order to keep up with it. All of these sections here, so for example, I'm calling the exact same model, and it has different prices when called from a different SDK. Same model, different price for some reason, right? You'll also notice that Azure will offer you GPT-4o, and they have no less than 5 different scopes upon which you can be charged. You can get a completely different version of GPT-4o in Sweden, for example, right, which is fine-tuned for all of the laws that they've got over there, and they charge you differently for it. And that price is more expensive in pay-as-you-go and less expensive if you're reserving the model. So this gets very hairy very quickly. And if you want to reserve directly from OpenAI, it's so complicated to understand what the pricing is. This is where you're renting GPUs from OpenAI in order to run the models on. It's so complicated to understand. The only way to actually get the right answer is to do multidimensional sampling. And this leads to my favorite quote on OpenAI's website, which is that they will give you a tracking system for this in Q2 of 2023. And that is still up on their site. You can go look at that, right? It's a mess. It's a complete mess. And so if you're going to try to understand ROI, again, you need to understand cost. And so understanding cost is very, very complicated. If you're going to take the number of tokens that you're using and multiply by the price per token, you will be wrong. Further, the cost of a request is not the cost of an agent. When the agent is running, it's making multiple calls, right? It's calling a whole bunch of different things. In fact, it's not even one model. The industry average is 3.5. So you have 3.5 different models, usually from different providers, sometimes with enterprise discounts, those of you with big enough companies here to have something like that, right? And it's going to be making calls across a series, a constellation of tools and services. And so understanding what the heck the agent is doing is extremely complex from a cost perspective. let's talk about time savings. So this one involves understanding how long it took for the agent to deliver on its intended outcome, which means you're talking about latency. But Gen AI latency is actually fundamentally different from traditional software as well. So we're all familiar with end-to-end latency, how long it took from the start to the end of whatever it is that I'm trying to do. But Gen AI introduces 4 additional types of latencies that are actually all relevant as well. The first of these is my favorite, is time to first token. So you ask a question, how long does it take the model to reason before it immediately starts replying with the answer? Now, the reason why this one is so interesting is because there's been multiple studies with probes done on the actual LLMs themselves that show that they answer the question before they ever start streaming back the remaining results. So in other words, you ask it a question, and it knows the answer. It figures it out before the first token comes out, and then it spends the rest of the time explaining it to you. And the way that you can convince yourself this is true is imagine you have a maze, and the maze has multiple entrances and multiple exits. And you say, hey, I want you to find the fastest route through this maze. And in order to do that, it has to figure that out before it starts giving you an entry point. So before the very first response where it says start here comes in, it has to actually figure out the maze. And so logically that makes sense, but it actually turns out mathematically that's the way they do it too, which is why the time to first token is typically about 6 to 8 times longer than the intertoken latency, which is the remaining tokens as they stream out, right? That you experience when you ask ChatGPT a question and you see all the text kind of coming out like that. That's what you're seeing is the intertoken latency. But this also introduces the concept of thinking before you respond, right? Because if you want to solve this maze more effectively, you don't want to limit yourself to having to respond right away out of the gate with the first step along the maze. And so this introduces the time to first completion token, which is a function of reasoning. We all have, typed a question in lately and it says thinking before it responds, right? Or reasoning or something like that, right? And every single one of those is basically using the fact that that TTFT, that time to first token, is essentially trying to solve, but it can't quite get there for really complicated things. So you give it more time, you give it more tokens to think about the problem and reason over it. And that means that before you actually start seeing an answer to your question, you're seeing it think. And so TTFCT, time to first completion token, is actually until you actually see the results start to come through. And then last but not least is output tokens per second, which is exactly what it sounds like. The reason why this one is interesting is that some models, the more stuff that they're working on, the slower they get near the end. And so Gemini is famous for this. It has a gigantic context window. You can have it work on tons and tons of stuff. But as it starts going and going and going, and it's processing a million tokens, you're getting near the end of its context window, this number starts to plummet. And so if you're trying to put this in front of a customer and understand, hey, how long is it going to take for this thing to finally complete its objective, the amount of data that it's processing will actually change these numbers over time. Something, again, totally new for Gen AI, right? You don't really have to deal with this in traditional cloud software. So understanding the latency is also complex. Now, last but not least, we have productivity. So imagine I'm a human, like I said earlier, and I can process 500 tickets a day. And now that I'm using my fancy new agent, I'm up to 1,000 a day. Yeah, let's do it, right? The agent is processing this on its own. The asterisk there is because some number of the things that the agent is doing will be wrong and will require a human to kind of verify that it's correct and sometimes redo it. And so was this a positive impact on productivity, right? How do you think about that? So this is a complicated problem, and so the only way to address it is that you have to break it up into steps. Step number 1 is split the problem into use cases. The technology is the implementation, but what you're trying to do is accomplish your business objectives, right? And so what are those business objectives that you're thinking about? Those are the use cases. You can think of accomplishing a use case as the objective of the agent. Summarizing a document, processing a support ticket, booking your favorite hotel vacation, whatever it is. Understanding use cases means understanding outcomes. How long did it take to achieve an outcome? How expensive was it to achieve an outcome? Was it successful? To what degree was it successful? Right? This is what's important. However, Gen AI is remarkably sensitive. You can go in and change an English language prompt, right? Like you can just put a comma somewhere. And as soon as you do that, it totally changes the entire dynamics of what the agent is doing. And so if you've got engineers that are experimenting with prompts, experimenting with data, experimenting with new models and architecture and code, you're not really going to have an understanding of what your use case is unless you also version it. You have to version this. So you have to be able to say, hey, when I went from this prompt to that prompt, this was the impact on my ability to deliver on that outcome. This was the impact on the time it took to deliver on that outcome. These are some example use cases which are objectives or outcomes driven. You notice I don't have Copilot written up here or agents, because those are not objectives. Those are not use cases. Those are tools to accomplish a variety of use cases. Every single one of these is an example of a scenario where there is actually an outcome, where you can say, yes, I did that, right? I wrote the documentation, I detected the fraud. Once you've got those, the next step is to associate quantifiable KPIs with those outcomes. It's not enough to say, like, oh, thanks, ChatGPT, you summarized that document, man, I like that, that was really good. Like, you have to actually put numbers behind this. It's not about the feelings, okay? And so here are some examples of KPIs for the 3 most common use cases that we've seen just talking with hundreds of enterprises. So for our chatbot, for example, we've got user satisfaction, thumbs up, thumbs down. How often does it deflect from my support staff from coming in, and how many turns was the conversation? Every single one of these things is numeric. And in fact, it turns out that in our conversations with folks about how they think about quantifying their KPIs, it resulted in 4 buckets. You've got Booleans, true, false, and every single time you account for Booleans, it essentially converts to a percentage. So for example, how many of was a user satisfied with this one chat? Yes, no? And if so, I can look across all of my chats and calculate a percentage of how happy my users are, right? Numbers, and then of course percentages, and then Likert, which are like 1 to 5 stars, 1 to 10 stars. If you can think of another one that I have missing here, I'd love to hear it, right? Again, a very common, quantifiable way about thinking about how to measure your KPIs. And so once you've got this sort of methodology, now all of a sudden you've got numbers. You've got numbers that are the data for the use cases and data for the agents. You've got numbers that represent the data of how you're measuring the success of those use cases. And so you combine them in step 3, right? Business value is a function of your KPIs and your data. ROI is not a KPI. ROI is determined by these 2 things, right? Again, KPIs and data. And so, for example, let's look at our financial value equation that we looked at earlier. This is ROI. Now, if we look at that marketing example, you can figure out what your net profit is as a result of these 3 things. And then cost is a function of identifying the cost of the mechanism, the agent, right, that was responsible for producing the ad. Let's look at time savings. This is going to be a new equation. It's going to look more complex than it is. I promise it's really not that hard. The S here is simply whether or not the objective was met to satisfaction of a reviewer of some kind, right? And then N is the amount of time it would take to normally accomplish a task, so for a human to accomplish a task. And then A is simply the amount of time it takes for an agent to accomplish a task. And so this one equation represents 3 different states. You've got the state where the agent is just banging on, it's doing great, everything is to satisfaction, and you're saving a ton of time. You've got the case where nobody's satisfied and you're losing a bunch of time because the agent is essentially burning all that time and you're not getting anything back. And then you have the more nefarious case where the agent is sometimes succeeding, sometimes not, or it's not saving you as much time as you would have hoped. And so if you look at our document summarization example, if you understand the size of the document, you can estimate the time it would take for a human to go through, read that, and summarize it, and then satisfaction is a function of their quality rating looking at the agent's outputs. So you can model time savings in this way. For the third, for productivity, this is more complicated, and to spare you guys on a whole bunch of messy math, I'm actually going to turn this into a sound bite that I'm going to repeat a few times just so you can kind of get this in. Your agent is improving productivity if the probability of it accomplishing the task successfully is greater than the time it takes for a human to verify that the agent did that, divided by the time it takes for a human to do it. And I'll say that one more time just so we gather that. Your agent is improving productivity if the probability of it accomplishing the task successfully is greater than the time it takes to verify divided by the time it takes to do it yourself. Now, this is for the special case where doing it yourself is equivalent to redoing the task. Because if you're an agent and you tell the customer on Expedia, hey, yeah, you can get a refund for that totally unrefundable trip, all of a sudden, this equation doesn't quite apply. So in other words, if the agent messing things up requires you to go spend a bunch more time to fix up after it, then this is a slightly different equation. You have to use that more complicated one at the top. Don't worry, there'll be questions at the end. This isn't a test. In summary, we defined agents as a workflow which is I'm incorporating a single step of Gen AI utilization into my existing traditional code, a pipeline where I've got a series of predetermined steps, or something that's truly agentic, MCP servers, tool use, I'm going off, I'm figuring out the world on my own. We define business value as either currency, time savings, or productivity. We talked about how in order to measure these things, you have to split up your agent into the use cases of what it's trying to accomplish and focus less on the technology and more on the business outcomes. What was the price to achieve that outcome? What was the time to achieve that outcome? Was it successful? To what degree was it successful? And for that, you define quantifiable KPIs. And then with all of this together, you finally have a mechanism to understand what was the business value of your agents. So going forward, we've all heard this phrase at this point, right? Has anyone not heard this? It was the big MIT report. Does anyone here believe that this is actually true? Anyone? It's not. It's not true. 95% of organizations are just not measuring their ROI, right? But there is ROI to be had here. Now, you're also hearing this one, the AI bubble is bursting. Does anyone here believe that to be true either? No, I see a lot of heads shaking no. You're all here because it's not bursting. We're all leaders in making this happen. The AI revolution is just getting started. Agents will bleed into absolutely every aspect of code. Today, an AI thing is a buzzword. It's a sales tactic. It's a marketing gimmick. It's like, oh yeah, we're agentic, blah, blah, blah. 5 years from now, that'll just be what software is. And so you need to understand exactly how this is going to impact your business, because this is going to be your business. Now, I mentioned earlier that I am the CEO of PayEye. When you got to pay for AI, come to PayEye. We're here all day. If you have any questions about measuring the ROI for business, for agents, Eric is here as well. And with that, I will take some questions.
Questions for Dave? Coming around with Mike. Coming up to you, ma'am. There you go.
Hello?
Hi.
Hi. Have you heard of the term agency tax?
Agency tax?
Yeah.
Tell me about it. Tell us all about it.
So basically, well, let me frame it properly. It's the extra work a user must do because the system stops instead of performing the task all the way through. So like, if you use Google Maps and it says there's traffic, and then you have to figure out your own route.
Yep.
If Waze just sees that there's traffic and then reroutes you automatically, like the additional human effort to complete the full kind of workflow is considered the agency tax. So I guess it's part of like an article I'm working on. I've been talking to some folks about it. I'm just curious if it seems like it folds into here, so.
Yeah, so there's two parts to that, right? The first part is I have to identify that the agent didn't do what I wanted it to do, which for giving me directions to go to McDonald's is fairly straightforward. To identify that, I didn't quite get to McDonald's, I stopped at the Subway, But if it's a more complicated, say, business objective, where it's producing a report, it's doing deep research for 30 minutes, it pumps out this like 20-page document. Now I have to go read that 20-page document. I have to verify, that's the V here, right? I have to verify whether or not it accomplished the objective. And if it didn't, then I have to rework it in some way, which is R in this example, okay? And so the rework time is, I think, what you're getting at, which is there's some amount of impact that I have to go through if the agent, it's actually probably V and R. They have to verify it, and then I have to do some rework time over the top of it. It's unlikely that both of these will be zero in a real production environment. I hope I addressed that.
Yeah, I think what I'm talking about doesn't take really the verification into account, but that's an interesting piece of it. Thank you.
Great.
Hi, great presentation. A question for you here. Between financial, time savings, productivity, it seems like there's more of a emphasis on the cost savings piece of it, but how do you then measure the agentic value in creating new business models or driving new revenue streams?
So creating a new business model or driving a new revenue stream so going back to our ROI equation, would be net profit here. But this does not assume that it's coming from savings, right? This can come from entirely net new businesses. my business would not exist without Gen AI, right? As would, dozens of others. Look at ChatGPT and OpenAI, right? The billions and billions of dollars that are funneling into them is net new revenue for someone. And so, yeah, absolutely. I think it just folds right into this. The savings here, the numerator essentially comes from either savings or from profits.
Hi. Great insights into how to measure the agentic ROI. Can you go back to the probability of success formula? Yeah, here, the verification time sometimes can be multifold, and then we never cross one because it is a probability. So you will never will be able to reach there in the scenarios.
So I think what you're asking, to repeat, is if V is extremely high, then can an agent truly ever improve productivity?
Right.
And the answer is, how high is it the time it takes for the human to do the task themselves? So I'll give you an example, and this is a complete shooting from the hip, right? Let's imagine that I was going to ask an agent to invent new physics. Verifying that is really a lot of work, right? I'm going to need a team of researchers are going to be poring over it. GPT-5 like Ultra Pro in some secret lab like pumped this thing out after like burning like a small city worth of power, right? But how long would it have taken us to do it ourselves? We don't know, right? And so it's actually possible that you don't know the answers, you don't know how to populate these variables, but this is a logical framework. It's not hard to convince yourself that if I'm spending too much time verifying it, then, like you said, it's never going to be the case that the agent will be able to improve productivity. And so there's also the sort of unspoken aspect of this is there's an error margin that you allow yourselves by not verifying it, right? You see this all the time when you open LinkedIn and you get all these messages from bots. Hey, so-and-so, I just noticed that you were amazing in all these incredible ways, and would you like to buy my stuff? Right? There isn't somebody that's reviewing those LLMs and like reading all of those messages before they just like spam you with 10,000 images. And so in that case, V is 0 and probability is great, right? Even if the probability of success is like minuscule, it's still greater because I'm not doing it myself.
Another question right here. Do you mind passing over there? Thank you.
Okay, this is a silly question. Let's say that I have a HR person, and that person, her job is only answer questions on what are my benefits, very static documents, very static questions. In order to replace her by an agentic, I have to keep it her to validate that everything that the agentic is providing to the customer is right, but also do I need the person that continue do the configuration for the agentic until the agentic, so I'm going to have 2 people right now until the agentic is fully trained?
I think your question is, I'm building a bot that's intended to replace people and get them fired. I'm just playing with you, right? And how do I do that most effectively, right? Because I'm cruel. No. So in order to get the most out of so this use case is a very common use case. I've got a support chatbot of some kind. It could be human resources. It could be, pick your favorite, like I want to ask questions about stuff, okay? There's going to be some amount of time where you're getting that thing up to speed, where you're training it on your particular, say, HR policies, where you're tuning it, you're adjusting it, and as you do that, this goes back to the versioning statement that I made earlier, you're measuring the KPIs at each step. You're measuring how happy are my users, right? Are they actually accomplishing the goals that they're setting out to accomplish, which you can define numerically in some way, a way that you can measure. And then as you experiment with new models, as you experiment with new HR data that you're ragging into the pipe, and this is a pipeline example, right? Is it getting better or worse? And then at some point, you call it good enough. Everybody here that's worked on AI, and I know that from the beginning, we're saying that 100% of folks here are AI folks and only 82% are Gen AI folks. Every single person in here that's worked on AI knows that you can work on AI until you're blue in the face. You have to define objectives, at which point it's good enough, because you can spend infinitely on this, right? You can always have data scientists like poring over like tiny little minutia. And so you have to figure out at what point you're satisfied with those KPIs. You set goals. And as soon as you hit those goals and you can measure over time that you're consistently hitting those goals, you're good. You can fire all the people you want, right? Just kidding.
Got a question back there.
Yes, hello, thank you for the presentation, really, really insightful. I mean, agents and agentic is on everybody's mind right now. I guess my question is, how does Pay AI fit into this? Like, what service do you provide for large corporations?
That's a great question. I'm going to use this time only because I was asked. I'm not here to, as part of the keynote, to sort of sell you the product. But PayEye does everything that you're seeing in an automated fashion. So we will measure all of the costs that go into your agents. We track things from the perspective of a use case. We track KPIs. We associate them to versions of your use case. We do all of these types of calculations in real time and show it all to you. And so we are here doing demos as well. Try to bring up this other. I'm working on a little clicker here. Thank you for that question, though.
Another question right up front.
Hi, first of all, great presentation. I work in a banking domain and I work on implementing AI and data and analytics domain. So the biggest problem we face is, here I could see the straightforward KPIs. But then for us, compliance efficiency, data accuracy, data governance, all are like the things that really matter. And generally we try looking for opportunities like where we can reduce the downstream, prevent data hubs. So in those scenarios, if I have to measure a KPI, so how exactly would you apply this framework over data and analytics pipeline where you implement LLMs?
So I don't know enough about your industry to give you example KPIs. But what I will say is that the only way that you can do just about anything where you're trying to measure improvement is to quantify it first, right? So one of the biggest pain in the butt questions that I get asked all the time is, hey, my developers are using GitHub Copilot, measure the productivity of that. And I'm like, cool, how would you quantify that, right? Is it number of lines of code that are getting spit out? Is it like how fast they're doing check-ins, even if the code is super broken? Like, what are the numbers that you would say, like, yes, if that number goes up, we're getting better? And if you can do that, right, and it doesn't have to fit into any of the stuff that I talked about, right? It doesn't have to be a Likert, a Boolean, a percentage, a number. If you can find another like way of quantifying and thinking about it that makes sense for you, that's the beginning of the journey, okay? And so what I would encourage you to do is to split the goals that you've got into subdivisible, quantifiable components. And then you can actually start to construct meta KPIs that are actually over the top of multiple numerical values that you're measuring, right? And so I can see how certain things increasing don't inherently mean that I'm getting more productive, I'm getting more revenue, I'm getting some more time savings, but a confluence of them together can all of a sudden start to mean those things. And so you can stitch these together in equations, again, so long as it's quantifiable. Is that helpful? We can talk more afterward, too.
For one more question. I know there's other hands up. Dave's going to be sticking around, so we'll be able to get your questions answered, but we've got one more right here.
Sure, thank you. I'm Saket from Citibank, and I work in business intelligence and reporting. And what we are also trying to explore is to use agentic frameworks in the business intelligence. So I'll just try to up on the same question what was asked before is, so GenAI or the agentic framework, it can help you to generate codes like PySpark or SQL to get answers if you are making a conversational business intelligence application. But the infrastructure of data plays a very important role there because if generation of PySpark code or SQL code can be really fast through using large language models or the agentic framework, but if the infrastructure is not that great, that code might take a long time to pull the data back with the accuracy concerns. So how do you think, how does a bank or the big enterprises should invest in the infrastructure that can hold up to the agentic frameworks, especially in the data science?
Yeah, so I think what I heard you say is, and you tell me if I'm right here, is that there is a confluence of things that are involved here, not just the LLM spitting out a result at the end of this, right? And so that's why, and it'll take me 3 hours to go back on this clicker, but that's why when I was talking about splitting things into use cases, it's technology agnostic. What is the use case? What is the outcome I'm trying to accomplish, right? How fast was I able to do it? Was I able to do it successfully? How much did it cost me? And to what degree was I successful? Those 4 questions are the questions to ask yourself. All of the implementation details about whether it's PySpark or a database or, there's developers that are in the mix or even humans in the loop, which is really common for multi-step agents and things like that. All of those things contribute to the cost, they contribute to the latency, they contribute to the productivity improvements, yes or no, right? Like it could go either way. So the underlying technology should not be your thing that you hang your hat on. Instead, version the technology choices that you're making. And so as you experiment with different PySpark implementations or different data clusters or different RAG pipelines and things like that, you can then look at all of the measurable components, back to the KPIs, back to the scenario, the use case that you're trying to accomplish, and you can see whether or not you're getting better, right? Like that's really the end of it. Hopefully that's helpful. And I think I'm out of time.
Dave Tepper, everyone. Round of applause for Dave.